Hi, the next exam question we're going to have a look at there is 2013, paper 1, question 7. It's a question on functions. So it's talking about two cylindrical tanks, which may seem like it should be geometry, but actually they're looking at a rate, and functions are always looking at rates. This time they're looking at the rate of how much the tanks fill over a certain period of time. So anytime you see rate, you're going to be thinking functions. So there's going to be a pattern, you can form a graph from it, and sometimes functions lead into calculus, not in this question. So again, I'd suggest pausing at the start of each part of the question, try the question and then check your answers. So there's quite a bit of data in the first part of the question. There's a bit of reading here, and you need to pick out what's the most important pieces of information. So when I approach a question like this with a lot of text, I like to get out a highlighter or a pen and underline what's important. So tank A had two important numbers there, 25 centimeters deep, and it was increasing, so plus 5 centimeters every 10 seconds. There's the important piece of information for tank A. Tank B then is 10 centimeters deep water, and it's increasing at a rate of 7.5 centimeters every 10 seconds. So we can pick out what's the important pieces of information there. Now the question asked you to draw up a table, so get out your ruler and draw a table, and it said to have a look at the interval over the next 2 minutes. Now it's going up every 10 seconds, so if you convert 2 minutes, it's 120 seconds, so that gives you an idea how long your table needs to be. So you can see here I've inserted a table and I filled in the times starting at 0 seconds right up to the 120 seconds, going up in 10-second intervals. So tank A started at 25 centimeters deep of water, and it's increasing by 5 centimeters every 10 seconds. So we're going to keep adding on 5, so 30, 35, 40 and so on until you fill up the table. So you can fill it up right up to the end. You should have 85 centimeters of water at 120 seconds. Now tank B was 10 to start with, and it goes up 7.5 every 10 seconds, so 17.5, 25, 32.5 and so on. You can keep filling it in. So you can see already that there's a difference in the rates, even though they started at different points. The rate for tank B is much faster filling up, so even though it started at a lower point, by the end of the 2 minutes it's actually more full. It's got 100 centimeters of water as compared to 85 in tank A. So looking at your table, it should be easy to make a prediction of when each tank is going to be full to 1 meter. Tank B was very straightforward, that it was already at 100 centimeters at 2 minutes, so that takes 2 minutes to fill it up. Tank B was only at 85 centimeters at the end of the 2 minutes, so it was going to take another 3 intervals of 10 seconds to reach 100 centimeters. So at 120 seconds it was 85 centimeters. At 130 seconds it's 90. At 140 it's 95 centimeters, and at 150 seconds it is 100 centimeters. And 150 seconds is 2 minutes 30 seconds or 2.5 minutes. So a very common question that comes up in functions is to write the rate as a formula. So you have to think about the constants, what's staying the same, and the variables, what's changing when you're making the formula. So what's changing in this question is the depth. So we're going to make that D, and we're going to make the other variable time T. Now, when we think about tank A, the constant is that there's always 25 centimeters of water at the start. And then we're adding on how many centimeters per second. Well, 5 over 10. 5 centimeters every 10 seconds. So what does that equal? Well, it gives us that the depth equals 25 plus 5 over 10 is a half t. And we can even check. 25 plus a half, and if we pick, say, 20 seconds, that equals 35. And if you go back to your table, you'll see at 20 seconds it was 35 centimeters. So my formula works. Tank B, then we're going to be talking about depth and time again. The constant is that you always have the 10 centimeters at the start plus 7.5 centimeters every 10 seconds. So what will that formula look like? Well, the depth equals 10 plus 7.5 over 10 is 3/4 t, the time. And again, we'll do our little check. 10 plus 3 over 4. And again, if we look at 20 seconds, you will get 25 centimeters, which, when you look back at your table, is correct. So we know they're right. So our two formula there, d equals 25 plus a half t, and d equals 10 plus 3/4 t. So in part D, you simply have to put the data from your table into a graph. I would use two different colors here to show your different lines. So I'm going to use blue for tank A, and that starts at 25. And it increased 5 centimeters every 10 seconds. So it went to 30 at 10 seconds. It went to 35 at 20 seconds, and so on. And I'm going to continue that line now. So you use a ruler now. I'm just doing a quick sketch. Now I've got a different color pen, red pen, and I'm going to do tank B. So I can see tank B started at 10 and it went up 7.5, so to 17.5 there at 10 seconds, and I'm going to continue on with that graph. So you can see there my tank B line that I've done in a different color, and that you can see the rate, even though it started at a lower point, it's filling up much faster. So part E then asks you find from your graph how much time passes before the depth in the water is the same in each tank. So it's quite clear from the diagram and even from your table that the point here where the two lines intersect is going to be the point where they are at the same height. And if you draw a line across from that point and down from that point, it says how much time passes before the depth of water is the same. So we're looking at what the question asked me was the time. So I'm going to be looking at this axis, and it is at 60 seconds. They're both at the same height at 55 centimeters. So there are two ways of verifying your answer to part E. Obviously you could see it on the graph, and you could also verify it algebraically, or you could verify it by substitution. So I'm going to show you both methods now, and you can choose whichever you think would be easier. There was 5 marks for this point. So essentially what you're trying to find out is, when does tank A equal tank B? Well, the formula for tank A was 25 plus a half t equals 10 plus 3/4 t. And you can rearrange that until you get all the numbers on one side and all the t's on the other. So you end up with 25 minus 10 equals 3/4 t minus a half t. So 15 equals 1/4 t. I just use a stabilizer then to multiply by 4, and I get t is equal to 60 seconds. So I verified it that way. The other way is by substitution. So just substitute 60 in essentially for t in the formula. So in tank A, d is equal to 25 plus a half, and I'm going to substitute in 60. And I find that that equals 55. centimeters. And again, for tank B, it's 10 plus 3/4 of 60. And again, you get 55 centimeters. So 60 seconds is the time when it is 55 centimeters depth. So either or of those, that was 5 marks. Now the whole question was a 40-mark question, so you'd be spending about 20 minutes on it. And if you have any questions, please make sure you ask. And if there's any other topics you want me to do a video on, just send me a message on Teams. Thank you.